like need to see it again, you can watch it. So I think I am now recording. So on Thursday, we reviewed how to sketch a rational function. We went over parent functions. We reminded ourselves how to find vertical asymptote, horizontal asymptote, and all my intercepts. So this is important. We're going to come back to this later today because we're going to keep doing these same processes. We did some limit notation, which we're not going to do more of today, but hopefully we'll look at that more in the future to keep practicing those ideas. And then starting today, we're going to do some problems where we do not have the same exponent on top and bottom. We're going to do a couple special cases. So the problems that we did when Thursday or whatever day it was were most ones that you've maybe seen before. These are some special cases we maybe haven't seen. And so we're going to start with one, actually. I've got x squared minus 9 over 3x plus 9, okay? When we have multiple pieces where it's not just like x plus something else, we want to factor it first. If we can get it in factored form before I do anything else. So let's factor this. X squared minus 9 is the same as x minus 3 and x plus 3. And then 3x plus 9 is going to be 3 times x plus 3. Cool. Okay. Well,
Ms. White?
Yeah.
Gabby told me to tell you that her iPad died.
Oh, I just added her in.
Oh.
No.
Okay. Well, never mind then.
Never mind. Sorry.
Thank you for telling me though, Haley. Gabby, you good?
Yeah, I'm fine now. It was just like dead for about 10 minutes, so I was like freaking out.
Okay. Unless someone else named Gabby DeLuca joined our group, then I'm not sure what's happening. So, okay, we're all here. Okay, I have this in factored form, and now I can cross out something on top and bottom. I've got this x plus 3 on both top and bottom, so I'm going to cross that out, and that gives me x minus 3 over 3. Well, now there's no more x's in the denominator, so this is no longer a rational function. Once I factored this down, this actually becomes a line. If you break this apart, this big fraction, into two separate fractions, it's like 1/3 x minus 1. So a note I'm going to make is that we factor, and if it factors perfectly, like if it factors nice enough that we cancel everything out, if it factors perfectly, we may not get a rational equation. We may no longer have a rational function to graph. You don't have to write anything that I write. These are just my thought processes, and this is if I was in your shoes, this is what I would probably write off to the side to be like, sometimes it looks like a rational function, but when we factor it, it's not. So that's what I would write, something along those lines off to the side. And so I'm going to graph this, but I'm going to graph this line, not the rational function, because when I factored it down, there is no asymptote. There is no whatever. It's just different than what we're used to. So let's go graph this over on our picture. I've got 1/3 x minus 1. So we're going to go to -1 on my x-axis, or my y-axis, excuse me. And then I'm going to go up 1 over 3. Up 1 over 3. Up 1 over 3. Same thing, down 1 over 3. And connect my line. Whoa, it went off the page. This is not a great to scale drawing, but I did my best. Pretend that's better. Cool. All right, so that was a weird example. That's the only one we're doing that goes away from being a rational function, but we will bring the idea of factoring down into our next couple problems. Any questions on what we've done so far? All right, if you're ready, I want you to go down to the next one, either scroll down on your iPad or flip your paper over, and we're gonna factor this first. So I'll keep the screen so you can see both of these things until after I factor, and then I'm gonna move it completely to the new problem. So I've got this new equation, it's x squared minus 4x minus 5, and then 5x squared minus 5. So we're gonna factor that. The numerator factors, okay, multiply to be -5, add to be -4, x minus 5, x plus 1. It's not great spacing. Okay, x plus 1. There we go. And then the bottom, I'm just going to do a GCF. I can take a 5 out of everything to get 5 times x squared minus 1. Ooh, but I can keep going. That's a perfect square difference of squares. So I still have x minus 5 and x plus 1 on top. And I have 5 and x minus 1 and x plus 1 on the bottom. This is the reason we hammer the idea of factoring in when you're in Algebra 1 and in Algebra 2, because we need to make sure that you know how to do this so I don't spend my time teaching you to factor. So if you still need help with factoring, come see me sometime outside of class. Okay, now that it's factored down, I have this common factor of this 1, x plus 1, that gets to get crossed out. We're going to deal with him in a second, but we're going to only now focus on my simplified version, my x minus 5 over 5x minus 1. We can go back up to a couple pages ago where we did our practice, or we did our little key, I guess, for finding vertical asymptote, horizontal asymptote, x-intercept, and y-intercept, and use that because we're doing that exact same thing here. So now, on this simplified equation, I need you to find VA, HA, x-intercept, y-intercept. And so since this is the first one we're doing today, I'm going to walk through it with you. If you're doing great, then you do it on your own. But if you want a little bit of assistance, I'm here. Remember, VA is when we set the denominator equal to 0. So 5 times x minus 1 equals 0. Divide by 5 from everything, which gives me x minus 1 equals 0. And then add 1 to both sides. I get x equals 1. My HA is looking at my exponents. You can either go from the beginning, I can look at these exponents and coefficients right here, or you can look at the new ones. It's an x and an x, okay. So since they're the same, we look at my coefficients. There's nothing in front of my x minus 5 in the numerator. So we just do a 1 out front, and we do 1 over 5 as my fraction of the coefficient. So my HA is 1/5. Anybody questions so far? Okay, now we need to do our x and y intercept. So to find my x-intercept, I set my numerator equal to 0. So I do x minus 5 equals 0. Let me zoom in so it's not so trashy writing. X minus 5 equals 0. So I add 5 to both sides, x equals 5. Okay, that's my x-intercept. Y-intercept, we plug 0 in for the x's. So y equals 0 minus 5 over 5 times 0 minus 1. 0 minus 5 is -5, and then 0 minus 1 is -1 times 5 is a -5. And then -5 divided by -5 is a +1. All right, so we practiced all of those yesterday, so this should just be like a nice little review, getting our brain working this morning or afternoon or whatever time it is. And so we're gonna graph these things. So we're gonna go graph our HA, our VA, our x-intercepts, and our y-intercepts. Again, nothing too crazy or new. We did this yesterday. Since my y-intercept, or sorry, since my horizontal asymptote is 1/5, I'm going to try and make my scale a little bit bigger. So I'm not going to do my tick mark super close. I'm going to try and go out a little bit so I can have more room to write stuff and show things in my picture. Since I'm drawing my own drawing and my own scale, I can make it as big or small as I want it to be. That's good enough. Okay. X and Y intercepts are at 5. 1, 2, 3, 4, 5. That was maybe a little too big, but that's okay. Y-intercept is at 1. VA is at +1, and HA is at 1/5. I'm not going to mark you off and be like, oh, you drew your thing at 1/2 instead of 1/5. Just put it somewhere between 1 and 0 and then move on with your life. It's close enough. I'll figure it out. And this is cool. I've got a point on both of my like little quadrants that I need to put my C's in. So I'm going to just connect my dots and, you know, approach my asymptotes as much as I can. So I'm approaching my asymptote, coming down like that, approaching my asymptote, this time going up, something like that. Doesn't have to be super pretty. It needs to go through the points I see, and it needs to get as close to the asymptotes as I can. So that's all we learned yesterday. What I'm going to add today is you saw that we had this like canceled factor right here. He still matters. I don't know if you learned this in Algebra 2. I can't remember if you did this in person or online, but when I taught Algebra 2, I know I talked about this. When we have a canceled factor, that gives me a hole or an open circle in my graph. So you set that factor equal to 0, and that gives you a hole in your graph. X plus 1 equals 0. So at x equals -1, there will be a hole, and that comes from my canceled factor. So we used our canceled factor to find that. How I'm going to draw that on my picture is I'm just going to erase a little part right where that -1 is. I don't even need you to find the y. I'm just going to make a big little circle right there, and I'm going to draw an open circle on my picture. So the only new thing we learned here is that we could have a hole when we factored it down. Any questions? Okay, zoom out so you can look at that. The next two on my paper are examples of when we have a slant asymptote. So I have x squared and then I have an x. When my exponent on top is bigger than the one on bottom, I have to do a division problem to find my HA, which will be a slanted asymptote like this. I'm going to move my screen really quick to show you what I'm talking about. Back here with my HAs, I told you that we look at our exponents. What are you doing? Oh God. I look at my exponents, and we're now looking at the one where we have x is bigger on top than it is on bottom. The exponent is bigger on top than bottom. So I told you yesterday it's a division, and it will give us a line. So now we're going to do two examples and see what that actually looks like. I know that sometimes we skip that at like Algebra 2 or depending on time, we would not necessarily do it here, but it's not too hard. Everything else is literally the same, but we're just going to add a division problem in. So let's walk through that. I've got this problem here. I just told you that we should look to factor. We can factor here, but it's not going to help us. So let's look at that very quickly. If I were to factor this, x squared plus 5x plus 4, okay, then it needs to multiply to be 4 and adds to be 5. Well, that would be x plus 1 and x plus 4. Okay, and then the bottom stays as x minus 2. Not super helpful because I just like can't cross anything out. So you're welcome to factor it, but this doesn't help us at all, so you don't have to do that. I'm going to do our normal order of things. We do VA, then HA, and then our intercept. So let's do our VA first. That process is still the same. We got to look at our denominator. X minus 2 equals 0. Add 2 to both sides, x equals 2. Okay, easy. Now we have to do our HA. The expression on bottom is what we're dividing by. So it's the thing on top divided by x minus 2. So when I do my division, I think most of us do synthetic. So that's what I'm going to do. If you're dying to see long division, ask me maybe outside of class and I'd love to show you that, but you'll get the same answer each way. If I do my synthetic division, I put my 2 in the house and I put all my coefficients behind it. 2 and then 1, 5, and 4. Let's divide. Bring our 1 down. Times 2, I get 2. 5 plus 2 is 7. 2 times 7 is 14. That gives me 18. Okay. A lot of us are really good at division. So I'm sure we got this part and you're like, all right, now what? What do I do with this information? Well, when we divide, we get to rewrite this as a new expression as x plus 7 plus 18 over x minus 2. What we want, though, is just the whole numbers. All I want is the x plus 7 part of this. I'm going to technically just cross off the remainder. He doesn't matter. Cross him out. We don't need him. You could get literally anything as a remainder. It doesn't affect anything with your graph. All I want is the x and the constant. This is an equation of a line. Y equals mx plus b. So my my y-intercept is at 7, and my slope is just 1. So we're going to graph that line momentarily. Again, we did our division because my exponent on top is bigger than the one on bottom. Anybody have any questions so far? Okay. The next step is our intercepts. We've been good at those, so let's go do our intercepts really quick. X-intercept is my numerator equal to 0. You can go straight from factored form, or you can do it from the beginning. We're going to have to factor it anyway, and since we already factored it out, I'm just going to put it, the factor is equal to 0, and that makes it easier for me to see my zeros are -1 and -4. Again, you can write x squared plus 5x plus 4 if you want first, but I think that's silly because I already factored it. Y-intercept, you plug 0 in for all my x's, so y equals 0 squared plus 5 times 0 plus 4 over 0 minus 2. Well, 0 squared 0, 5 times 0 is 0, 0 is 0. So I'm left with y equals 4 over -2, which we know is -2. What are you doing? Nope. Okay. My iPad's playing games over here, so I hope it cooperates for the rest of class. Okay. All right, I have all my pieces. This is all we found before. The only thing that was new is my HA. Any questions? All right, we're gonna go sketch. I'm gonna graph my normal things first. I'm gonna graph my intercepts and my vertical asymptote, and then I'm gonna go look and see what my horizontal asymptote should be. Since I need to graph it through 7 though, I want to make my scale like a little bit smaller because I want to get to as many numbers as possible. So as I do my graph, I'm going to try and make it like kind of small. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, that's 11. And then the same thing over here. 1, 2, 3, 4, 5, 6, 7, 8. Again, scale's not perfect. Try your best. My negative x's look a little funky, but we'll deal with those later. So let me go graph my asymptotes and my vertical asymptote, my asymptotes and my intercepts, I'm sorry. 2 is my x asymptote. Oh, there we go. And then my intercepts are at y equals -2. And then x equals -1, 2, 3, 4, -4. My slant asymptote is not just a straight horizontal line, it's gonna be at an angle. So I'm gonna go graph that. x plus 7, go to your 7 on your y-axis, and then do your slope of up 1 over 1, up 1 over 1. 7, up 1 over 1, up 1 over 1. Draw enough points to get a line. My scale's not great. I should be hitting it at 7, not at like 10. Whoa, go back. Seven, 6, 5, 4, 3, 2. That's a little bit better. For any of you wondering, my scale was just really bad, so I just changed it a little bit. This looks a little bit more even. All right, so I have my intercepts graphed, I have my asymptotes, and I have my horizontal asymptote. When we had our normal graph, we had like 4 quadrants, like a top right, top left, bottom right, bottom left. Now that I have a slant, I still have 4 areas to graph. I just have like some that are a little bit smaller and some that are a little bit bigger than others. They're just not all equal. So check this out. I have a green area right over here. I have a red quadrant right here, I guess. I have, oh, I already did green. I have a yellow one over here. And then at the top, it's kind of running into my graph from above. So I'm just going to erase that for now. I've got like a little purple section right up here. And I actually am going to make that a little bit bigger. Of a pie piece and not purple because we obviously can't see that. We'll do orange. Since I've got points in that red quadrant, I'm going to go catty corner again. So since I'm in the bottom left, I have to go to the top right one, which is now the orange quadrant. So I'm going to draw C's in both of those quadrants. In this bottom one, I can draw it through the points that I see. So I've got these points right here that I just drew in the red quadrant. And I'm going to do the same idea in the orange one. It doesn't have to be exact. I just need to know that I've got points up here. So kind of approach your axes and call it a day. I don't need specific points. We're just sketching. It's not specific. And then I don't have anything in the green and yellow ones because those are not being used right now. So here are my graphs here and down here. Any questions so far? All right, we got one more to do, and then we're going to move on to new stuff. You don't need to factor this one. You can if you want, but why don't you take a minute? I'm going to do attendance. You see if you can find the VA, the HA, and the intercepts. I'll join you in 1 second. See what you can do. Oh, I lost someone. I'm going to show my work, so check in if you need it. If you're doing okay, though, keep working. You got it.
Miss White.
Yeah. Yeah, May?
I keep getting kicked out. Is this is going on Schoology, right? The video?
It'll go on YouTube, yeah. Are you like missing?
Okay, thank you.
Yeah.
Yeah, I keep missing problems. Glitch.
Yeah, and you're glitching for me. So I will, as soon as class is over, I'll post this and so you can go back and watch it. Thanks, May.
Okay, thank you.
All right, I got my VA solved for. Now we're gonna do our HA where we have to do our multiplication or our division. This time I've got -2 in the box because the bottom is x plus 2, not x minus 2, so it's negative. Carry that down. Oh, not that. Carry the 1 down. I get -2, 0. That gives me 0, which is -3. Remember when we do our HA, we don't need our remainder. So you're welcome to not even write it, but I write it to show that I know what it's supposed to be, but then I'm going to cross him out because I don't want him. And this is going to be the equation I use. You also don't need to write +0 because that's redundant. It's already stated. Essentially, you don't need to also write it, but I want to write it just in case we forget where my vertical asymptote is supposed to go. Or sorry, where my y-intercept is. Sorry, all confused. Now I have to do my x and y-intercept for this function. And when all my zeros cancel for my y, I get -3/2. I don't know if I've said this yet to you guys today, but I'll say it over and over with these rational functions, is you often get a weird number. You often get a weird fraction decimal thing, so don't be afraid to do that. Now that I have all my pieces, I want to graph it. I don't need my graph to be scaled as small as last time because it's just x plus 0 is my slopes, or is my horizontal asymptote, so I don't need to go like as high up on the graph as I did over here. I know I got rid of this graph over here, but we'll call it there. I don't need it to be as big, so I don't need my scale to be as small. Draw my axes, 1, 2, 3, 4, 5, 6. Graph your asymptotes and your intercepts. -3, +1, 3/2, -2, and then y equals x. So I'm going to go through my origin up 1 over 1, up 1 over 1, up 1 over 1, down 1 over 1, down 1 over 1, and then make as good of a line as I can. Ooh, this is not straight. All right, that's as good as those lines are going to get. All right, good. Again, I've got my 4 little spaces. I've got this orange quadrant over here. I'll do a yellow one up here. I'll do a pink one over here. You don't have to color your quadrants. I am just proving a point, and it's a lot easier to say the orange one and the pink one is where our graph goes, as opposed to saying the top left and then the bottom right, because it's a little confusing to look at those. The nice thing is I have points in both of the quadrants I need to draw my C in. So I've got a point in here in the orange quadrant and 2 in the pink one. So I'm just going to draw a C through that point and get as close to the axes as I can. So draw my C. Draw my C. We don't have anything in the 2 blank ones. because you never have something in all four of them. You just have the two that are across from each other. And so I have mine and the two across from each other, the top left and the bottom right. Okay, what we learned new today was that there was a special case. So number 4 was a special case where we didn't even get a rational function. We just got a line. In number 5, we reviewed that we could have a whole that comes from a canceled factor. And then in 6 and 7, we had to do slant asymptotes. So now we have examples of all of those things. And now we are officially done with 2-6. And so I'm going to assign that for Tuesday. So your 2-6 homework will be due on Tuesday. And after your class, I'll go put a little box on Schoology to remind you as well. And that's good because doing the 2-6 homework will help prepare you for the quiz. So that's a good thing for all of us. Any questions? Okay, we're gonna spend the last part of class starting 2-7. So I'm gonna move my screen. You go ahead and scroll or turn your page or scroll down to the 2-7. I wanna try and get through all 4 of these problems. They're all the same process, but they all give different examples. So if you're confused, make sure you stop me, but also make sure sometimes by just listening and then catching back up, you'll understand kind of a question maybe you would have had before. So I've got 4 problems on this side. We're still looking at rational functions, but now we're solving algebraically. And we're gonna do something where I call it clearing the denominator. We're going to clear the denominator, which means I don't want anything in the bottom of my fractions. So in all of these functions, when I say solve, you want to multiply by whatever's in the denominator by everything in order to get all real whole numbers. In this case, I'm going to multiply by x by everything. X, x, x. When I multiply x by x, I get x squared. X times this 3 over x, well, since there's an x in the denominator, these x cancel and I'm left with just 3. Then I multiply x times 4. This is a common mistake. Sometimes we forget the other side of the equation, so make sure you do x times 4 as well to get 4x. All right, cool. Now we're here, and now I've got like an algebra 1, algebra 2 equation. Move everything to one side, and then we're going to see if we can factor, and if we can't factor, we're going to quadratic formula. So clear the denominator, move everything to one side, and then we factor or quadratic formula, whatever way we need to do. I'm gonna minus that 4x over here, so I've got x squared minus 4x plus 3 equals 0. Remember to be really careful so you're not combining terms that don't get to be combined. So x squared and 4x are not like terms, don't combine them. All right, this one I actually can factor, so we're gonna do that. Always look to factor first. You can quadratic formula, but sometimes it leads to mistakes that we don't need to do. So I'm going to factor x and x, multiply to be 3, add to be -4, -3, -1. Okay, that makes -3, that makes -1 is -4, perfect. Then I'm gonna set each of those equal to 0. You can do this step in your head if you're getting good at it to know that x equals 3 and to know that x equals 1. But in case you forget, or sometimes with fractions, I can tend to not know which way the fraction will go, so I like to do this just in case. So x equals 3 and 1. Okay, now it's important that we talk about something now. Have you guys ever heard of the word or the term extraneous solution? I think some of you did it back in Algebra 2, but no one in my other class remembered what it was. Does it? Any of you guys remember? If not, that's okay.
I remember the word.
So Jared, you know that you've done it, you just don't remember what it means.
Yeah.
Yeah, that's where my other class was too. Is that kind of where everybody else is?
Yeah.
Yeah.
Awesome, thank you. So when we've done it, we just don't remember it. It's basically, if I were to plug this back in, it doesn't make my equation work. So I have a not very mathematical, serious definition, but this is what I think of. It's a solution we find, so it's a solution that we found when we solved. but when plugged in, doesn't work. I guess it doesn't work. I know sometimes you're like in Algebra 2, they might have made you plug it all the way in and solve out to see that it works. So like you would have had to do, okay, like 3 plus 3 over 3 equals 4. Like, does that work? Okay, 3 plus 1 equals 4. Okay, yeah, that works. And then 1 plus 3 over 1 equals 4. Is that okay? Okay, well, that's 1 plus 3, so that's okay. You do not have to do that all the way out here. The only thing I care about is if I were to plug any of those solutions in for x, it cannot make my denominator equal 0. And if it does equal 0, then that's an extraneous solution. So think about it. If I were to plug 3 in here, 3 over 3, well, that doesn't make my denominator 0, so that's okay. That's good. And then if I were to plug 1 in, that'd be 3 over 1. That's also not 0, so that's okay. I don't need you to do this. No need for that. If you want to, go for it. But all I care about is as long as it does not make my denominator equal 0, then it's okay, it's a solution. All right, let's keep going. Let's do another one. All right, this one, my denominator is x minus 4, so I'm gonna multiply by x minus 4 to everything. I am careful here, I don't distribute until I have to, so I'm gonna do x times x minus 4. I'm not gonna multiply that through until I'm done. X minus 4 times 1 over x minus 4. Well, the x minus 4's cancel, so I just get 1. And then 0 times anything is just 0. Now I'm ready to distribute. X squared minus 4x plus 1 equals 0. Cool, cool, cool. Everything's together. Ugh, but I don't have the ability to factor this. This doesn't factor. So we got a quadratic formula. That's okay. We know how to do that. X equals 4 plus or minus 16 minus 4 times 1 times 2 times 1. Everyone with me? Make sure you tell me if I'm going too fast. 4 plus or minus root 16 minus 4 over 2. Well, 16 minus 4 is 12, so I've got 4 plus or minus root 12 over 2. Ooh, and 12 is not a perfect square, but it has a factor that I can take out. So I can take out a 2 because root 12 is the same, nope. Root 12 is the same thing as 2 root 3. Oh, and if we remember back from like a long time ago, if all 3 of these have a common factor, then I get to factor that out. So I can take a 2 out of all of these things. 4 divided by 2 becomes 2. And then the other 2's just cancel out to be 1. So I get 2 plus or minus root 3. That's my answer. If I were to plug it back in up here, if I had 2 plus or minus root 3 minus 4, that would never, ever, ever equal 0. So that's fine. You don't have to plug it all the way back in to solve. We just know it would not equal 0. So 2 plus or minus root 3 is an okay answer. Now you might be thinking, okay, Ms. White, you talked about this extraneous solution and we haven't talked about it yet. Well, the next 2 examples both have an extraneous solution. So let's get on to solving those. Any questions so far? Okay. On this one, I have a denominator of x minus 1 and a denominator of x minus 3. Ooh, and then I've got this ugly thing over here, but let's factor it and see what happens. X minus 3, x minus 1. Those multiplied to be positive 3, it minuses to be negative 4. Okay, cool. Oh, nice. The good thing about that is I already had an x minus 3 that I was going to have to get rid of, and I already had an x minus 1 that I was going to have to get rid of. So we're multiplying everything by both of them, x minus 3 and x minus 1. Okay. The first one, when I multiply this first equation by x minus 3, x minus 1, well, the x minus 1's cancel. So it's just 2x over, I know it looks like 2 minus x here, but it's 2x times x minus 3, because the x minus 1's cross each other out. When you do the next one, I've got x minus 3's cancel each other out. So I've got 1 times x minus 1. And then the last thing has both an x minus 3 and an x minus 1 on the bottom, so both of them cancel out, and we're just left with 2. Clearing the denominator is what I'm doing, and that makes it so much easier to solve. So now I'm going to distribute through, combine like terms, factor, simplify, quadratic formula, whatever, to solve. 2x squared minus 6x plus x minus 1 equals 2. We are going to combine these like terms, and I'm actually going to minus 2 in this term as well, just so I can get everything together. So I get 2x squared minus 5x minus 3 equals 0. You can definitely quadratic formula that, but that's going to take a lot of time, so I'm going to try and factor it first. 2x, x, negative 3, so I've got 1 and 3 to play around with, and I want it to add to be negative 5. If I did 3 and 1, negative and positive, that'd be 1x minus 6x. Oh, and that would be negative 5x. So these are my two factors. 2x plus 1 equals 0, and then x minus 3 equals 0. Minus 1, 2x equals negative 1. Divide by 2, x equals negative 1/2. And then x equals 3. Okay. If I were to plug this in, negative 1/2 would be okay. It would not cause any problems. Negative 1/2 minus 1, not 0. Negative 1/2 minus 3, not 0. But if I plug this negative or this positive 3 in, this guy would become 0 in the denominator, and that's a problem. So because that would be 0, that is not okay. So the only solution is x equals negative 1/2. My extraneous solution would be x equals 3. If I were to plug 3 in, it would give me 0 in the denominator, which is not good. Okay, I really do want to do this last one, so I'm going to push through. Does anyone have any questions real quick? Okay. I've got x on the denominator, I've got x plus 2, and then I've got this x squared plus 2x. Ooh, but it factors to be x times x plus 2, which is all I needed. I had an x, and I had an x plus 2. Perfect. Let's multiply everything by x times x plus 2. The first equation becomes x minus 3 times x plus 2. The second one becomes 3 times x. And then the last one is just 6. I do multiply that x times x plus 2 times 0, but we know that's just 0. Distribute through. X squared plus 2x minus 3x minus 6 plus 3x plus 6. Ooh, before I even start doing anything else, I can cancel some stuff out. I've got a negative 6 and a positive 6. Bye. I have a positive 3x and I've got a negative 3x. Bye. I'm just left with x squared plus 2x equals 0, which is just a simple GCF to factor out. I first canceled my, cleared my denominators by multiplying by x plus 2 and x. I distributed, and when I went to combine terms, I found that the 3x's went away and the 6's went away. So I just had x and x plus 2. And so now my zeros are 0 and negative 2. If you look back at our equation, if I were to plug 0 in, I'd have a problem. 0 is just x. Oh, that's not good. That would be a denominator of 0. Bad. If I plugged negative 2 in, I'd also have a problem here. Negative 2 plus 2 is also 0. This problem actually has no solutions. And that very professional writing I have right there. No solutions. It has two extraneous solutions. Both of its extraneous solutions are x equals 0 and -2, but they don't count because they make my denominator equal 0. Okay, that's all we're getting through to today. Does anybody have any dire questions that need to be answered immediately? Okay, I'm gonna stop sharing my screen. I'm gonna stop my record when I can.